Welcome to part 2 of our Quantifying Forces series of labs. Like I said yesterday, probably, I wouldn't be here for today. I wanted to show you the setup, just as a reminder, so you're good for collecting data for today's lab. All right, what we are doing is exploring the relationship between the spring force and how far a spring stretches. So relationship between spring force and the displacement of the spring, which is how far the spring stretches and not the length of the spring. Okay, to set this up, you have a table clamp here, and a rod and an iron ring that has a string and a hook already attached to it. If I am able, I'll have this all set up for you already, but if not, then you'll have to set this up. So you just have it so the ring is facing out, and then you're going to test 2 different springs. All right, you'll get 2 different colors, 2 different lengths of springs. So I have a long yellow spring here. You just hang it from that hook, and then what you're going to do is take a cup, our fancy physics cups, which are just duct taped solo cups with a hook on top, and you're going to hang it from there. All right, so this is the setup. Okay, first, let's talk about how to measure the displacement of the spring or the stretch length. You're going to measure not how long the spring is, but how long the spring stretches. So right now with this setup, this is our equilibrium state with no mass added. We do have the cup. The cup has a very small mass. This cup, for instance, is 17 grams or 0.017 grams or 0.017 kilograms. So it's not affecting the length of this at all. And this is our initial position. All right, so you'll measure this initial position. How you want to do that is up to you. If you can attach this somehow to here, your meter sticks to the side so you don't have to hold it. Otherwise, some groups just like put the top of the meter stick up against the bottom of the iron ring. Then they can measure like down to either the bottom of the cup or the bottom of the spring. It doesn't matter which you choose to measure to the bottom of, as long as you're consistent and always use that as your measuring point. Okay, so whatever it is now, that would be your initial position. So for instance, right now, the bottom of my cup is at the 60 centimeter mark, and that is essentially my 0 position. Okay, then I'll add mass, and we'll go over this in just a second. But you'll add some mass, it'll stretch the spring out, and now what I want to measure is how far did that stretch. And so if I look here, now it's stretched down to about 68. Make sure you're actually getting down low and looking at it from, that eye level to see. So it stretched from a position of 60 down to 68 centimeters. So what you're going to record is that change in length, which would be the 8 centimeter difference. So that change in length is what you're going to measure for your delta X or stretch distance. Okay, second, we also want to measure the spring force. Now, when you're doing this, you're going to record actually the mass of the cup and everything in the cup. So you're going to record the mass using a scale. So for instance, right now, this cup with this mass, it has a mass of 225 grams. You're going to record that as kilograms, so that'd be 0.225 kilograms, and that will be the mass. Now, before we put it into the graph, we're going to convert that to a force. Okay, how much force? Well, the force that is pulling down on the spring is equal to the force of gravity acting on this cup, because the forces acting on the spring are balanced. All right, so the force of gravity pulling down on the cup will be equal to the force of the spring pulling up on the cup. So we'll use the equation from the last lab that we did, part 1, where we compared the force of gravity to mass to find that. All right, that will give us good results. It's one extra little step, but it's a little bit tricky to set up the force sensor and make measurements with this, just because the springs tend to be bouncy, and so you get weird force measurements sometimes. So we avoid doing that for this particular lab. Okay, so that is the setup. You're going to use the scale to measure the mass, record the mass, but then we'll convert it into the force using the equation from the last lab. Now, if at this point we haven't gotten to that, if we haven't actually gotten to the equation, so you don't know what the equation is for the force of gravity, that's fine. Just record the masses, and then when I'm back or when we go over that and have time, then we'll convert that to the force, the spring force acting on the spring. Okay? So a couple tidbits on this front. When you are doing this, be careful. I do want you to have a good range of masses, so don't all do like really wimpy small masses when you're doing this, but be careful, because if you do too much mass, you will destroy your spring. Okay, so the goal will be for you to complete this without wrecking your spring. Okay, if it stretches too far, the spring will like no longer be springy, or it'll wreck the spring, it'll pull it apart, and it'll actually change the measurement, the stretchiness of the spring, if you will. So avoid that. And it will depend, like I can't give you a hard and fast number, like don't go over this amount of mass, because each spring is going to be different and be able to hold a different amount of mass. So like this one is pretty strong. This is a pretty strong spring, so you're not really going to run into a problem. Your cup will probably break before you get to a mass that's too much. But just be careful. If it feels dangerous, then don't do that. Okay, same thing. People like to make their spring bounce. I don't care, it's fine if you do that, but when you have a lot of mass on it, if you throw it down and make it bounce a lot, you're gonna damage your spring, and I won't be super happy if I come back and all my springs are wrecked. So try to avoid doing that. Try to avoid it bouncing as it's going. Also, it makes the measurement for length harder, but that's a separate thing. Okay, so for the slab, because you're measuring the length and it's a static system where the spring is not bouncing, what we're going to do is, instead of doing multiple trials for each spring, you're just going to record a lot of different masses. So we're going to record 10 different masses for each spring. So make sure you have 10 different amounts of mass, and again, spread those masses out so you have some that are pretty light, others that are pretty heavy, and again, how big the mass gets will depend on how stretchy your spring is, because if it gets, if you have a wimpier spring, you'll need to use smaller masses than obviously if you have a little bit more taut, tight spring. Okay, the masses don't have to be evenly spaced. You're going to be grabbing masses out of just my box O mass, so you're not going to need, it'll be difficult to keep them evenly spaced. Just make sure they spread out from a little bit of mass to a lot of mass. As long as you have 10 like clearly different masses, you'll be fine. All right, that's it. Make sure you collect the data. If you're able to graph, because you can convert to the force, then you can put your data right into Pivot. Otherwise, wait until we go over that, and then you can graph that. All right, thank you. Good luck. Get good measurements, and we'll see you soon.